Right now, at this exact moment, a mountain in the Philippines is exhaling 2,428 tons of sulfur dioxide every single day. A poison gas output so enormous that NASA satellites can track it from orbit as a spreading brown stain across the South China Sea. And that number is not the alarming part. The alarming part is that on a single day in March 2026, that output spiked to 7,633 metric tons, the highest recorded in 15 years. And the volcano did not erupt. It just breathed. It breathed, and then it kept breathing, and the lava kept flowing, and the seismometers kept ticking, and the scientists at the Philippine Institute of Volcanology and Seismology watched their instruments and issued the same careful, precise, devastating language they have been issuing for over 100 consecutive days now, that a hazardous eruption remains possible and that the system is not winding down. But that is not even the real story. The real story is not about one volcano. It is not about one island. What is happening on the slopes of Mount Mayon right now is a window into something far older and far larger. A geological conversation that has been happening beneath the Philippine archipelago for millions of years. A conversation written in fire and stone and the bones of the dead. And what the data actually shows is that the mountain, the people of Albay province have farmed and fished beneath and built their lives around for 4 centuries, is doing something now that the geological record says it does before its most catastrophic events. The instruments are in place. Detection is possible. Prediction is not. And that gap between what the sensors can see and what the future contains is where 108,000 people currently live. Let us start with the mountain itself, because you need to understand what Mayon is before you can understand why what it is doing right now matters. Mayon is not just a volcano. Mayon is considered the most geometrically perfect stratovolcano on Earth. From the Albay Gulf, it rises 2,162 meters in a near-perfect cone, so symmetrically beautiful that generations of Filipinos have built their national identity around its silhouette. It appears on regional seals, in paintings, and the dreams of children growing up in its shadow. But that beauty is structural. That cone shape is the result of 4,000 years of repeated eruptions, layer after layer of lava and pyroclastic material stacking on top of each other, in exactly the pattern that makes stratovolcanoes the most dangerous type of volcano on Earth. Not the most dramatic, not the most explosive in the moment, the most dangerous. Because they build pressure, they store it. And then, when the conditions align, they release it all at once. Mayon sits on the Pacific Ring of Fire, which is not a metaphor but a physical fact. A 40,000-kilometer chain of subduction zones encircling the Pacific Ocean, where tectonic plates grind and dive beneath each other, generating 90% of the world's earthquakes, and more than 75% of its active volcanoes. The Philippine archipelago sits at one of the most complex nodes in that chain, where the Philippine Sea Plate, the Eurasian Plate, and the Australian Plate all converge within a few hundred kilometers of each other, creating a geological pressure system of almost incomprehensible scale. Mayon is not a geological accident. Mayon is the inevitable product of that pressure, finding its way upward through the crust. And right now, in April 2026, that pressure is actively expressing itself through 4 million cubic meters of molten rock that have been discharged from the summit since January and are sitting on the volcano's flanks, still hot, still moving, finding the paths of least resistance down channels that lead directly toward the towns and farms and fishing communities of Albay province. 4 million cubic meters. That number requires translation. 4 million cubic meters of volcanic material is roughly equivalent to 1,600 Olympic swimming pools filled to the brim. Except instead of water, you're filling them with molten andesite rock at temperatures between 700 and 1100 degrees Celsius, dense enough that a single cubic meter of it weighs over 2 tons. The total volume of lava and volcanic debris that Fivolks measured on the slopes of Mayon as of mid-February 2026 was 64 million cubic meters. By April, with the eruption in its 100th day and still ongoing, that number has only grown, and it has not gone anywhere. It is sitting on the flanks of a 2,462-meter mountain that also happens to sit in one of the most typhoon-prone regions on Earth, which means that every ton of that volcanic material is also a lahar waiting for the right rainfall event, a lahar being the volcanic mud flow that has, in the historical record of this very mountain, buried entire towns so completely that their ruins were not rediscovered for decades. Here is where this story becomes genuinely alarming. The eruption currently underway at Mayon did not begin suddenly. It was announced months in advance by the mountain itself, in a language that the geologists at Fivolks were trained to read but that the global news cycle almost entirely ignored. Beginning in November 2025, rockfalls from the summit lava dome became more frequent. A total of 599 rockfalls were recorded in November and December of 2025 alone, an average of 21 rockfall events every single day. On December 8th and 10th, photographs of the summit dome revealed something geologists call lava spines. dark, rigid fingers of solidified magma being pushed upward through the crater floor by pressure from below, the geological equivalent of a fist pressing through a sheet of rubber. On December 31st, 47 rockfalls were recorded in a single day, the highest number in any single day of the entire previous year. Ground deformation sensors, instruments so sensitive they can detect the swelling of a mountain by a matter of millimeters, had been showing anomalous readings for 18 months, with the eastern and northeastern flanks of Mayon inflating measurably since mid-2024. By the time the alert level was raised to level 2 at 6 in the morning on January 1st, 2026, the mountain had been warning anyone who was listening for well over a year. Then, on January 6th, 2026, the lava began to flow. And it has not stopped. Think about what that means. As of April 18th, 2026, Mayon has now been in continuous eruption for over 100 days. Over 100 days of lava effusing from the summit crater, feeding 3 established flow channels down the volcano's flanks, the Basud Gully on the eastern flank, now carrying a lava tongue 3. 8 kilometers long, the Bonga Gully on the southeastern flank, with flows extending 3. 2 kilometers, and the Miasi Gully on the southern flank with 1. 3 kilometers of active lava. Over 100 days of between 169 and 287 recorded rockfall events every 24 hours. Over 100 days of volcanic earthquakes, tremor events, pyroclastic density currents, ash plumes rising up to 1 kilometer above the crater, and a crater glow so intense it is visible to the naked eye from communities kilometers away at night. The system is not dormant. The system is awake, and it has been awake without interruption for more than 3 months. Now think about the people who wake up every morning and can see that glow from their window. The province of Albay, which sits in the Bicol region of southeastern Luzon Island, has a population of over 3 million people. Legazpi City, the provincial capital, sits within visual range of Mayon's cone, a city of approximately 220,000 people, where the volcano's silhouette appears on the horizon like a daily reminder of where they live and what they live beneath. The communities most directly in the path of the current eruption are smaller. Camalig, Malilpot, Guinabatan, and Tabaco City, all in the shadow of the southeastern and eastern flanks, where the 2 longest lava flows are advancing. These are communities where the morning routine involves checking the FIVOLK's bulletin before checking the weather, where farmers talk about the eruption, the way farmers elsewhere talk about the drought, not with panic, because panic is not sustainable over 100 days, but with a kind of measured, exhausted vigilance that the outside world almost never sees. Ask those farmers what they want to know. They will ask you the same question the scientists cannot answer. Not whether this gets worse, but when. Because here's the thing that the scientists at FIVOLKs are careful to say, and that careful language carries its own warning. Alert level 3 on the Philippine 5-tier scale means intensified magmatic unrest, with the possibility of a hazardous eruption in days or weeks. It has meant that since January 7th, 2026. Level 4 means hazardous eruption is imminent, possible within days. Level 5 means hazardous eruption is in progress. Mayon has been at level 3 for over 100 days, which in geological terms is not a reassurance. It is a sustained warning. The difference between a level 3 volcano that slowly exhales its pressure and a level 3 volcano that escalates to level 4 and then level 5 within hours is a difference that no instrument currently in existence can reliably predict. And if the alert level rises to 4, the evacuation zone that must be cleared jumps to 8 kilometers from the crater, and the number of people inside that zone who would need to move is approximately 40,000. This is not a theory. This is documented geology. And the most devastating proof of what documented geology looks like lies in the ruins of a church that still stands on the lower slopes of Mayon, 7 kilometers from the summit, its bell tower rising above the Lahar fields like a stone monument to the date of February 1st, 1814. On January 31st of that year, more than 200 years ago but preserved in accounts so vivid they read like dispatches from a war, earthquakes began shaking the slopes of Mayon with increasing frequency through the night. The people of Cagsawa, a thriving colonial-era town on the southern flank of the mountain, gathered in the Church of St. Bartholomew, because in 1814 the church was the strongest building in the town, and the instinct to seek refuge in the strongest building was entirely reasonable. At 8 in the morning on February 1st, 1814, Mayon produced what volcanologists now classify as a Plinian eruption, a sustained catastrophic column of gas, ash, and pyroclastic material that rose 50 kilometers into the stratosphere. Not 5, 50. A column of superheated debris reaching to the edge of the stratosphere, visible from the sea, from neighboring islands, from a distance of hundreds of kilometers. Below that column, down all 40 of the ravines that radiate from Mayon's summit, pyroclastic density currents, what geologists call PDCs and what the people of Albay know as Uson, the burning cloud, swept down the slopes at speeds of up to 200 kilometers per hour. You cannot run from an Uson. By the time you hear it, it has already arrived. The volcanic deposits reached depths of 9 to 12 meters along the affected slopes. The town of Kigsawa was not damaged. The town of Kigsawa was erased. 2 other towns were completely destroyed, 2 more partially devastated. Ash fell so thickly that witnesses described the sky going entirely dark at midday. The death toll was approximately 1,200 people. Many of them died inside the church, where they had gathered for safety, buried under lahars and pyroclastic debris that entombed the building so completely that only the bell tower remained above the surface. That bell tower still stands today. You can visit it. You can stand next to it and look up at the perfect cone of Mayon rising in the background and understand in your body, in a way that no statistic can convey, that this has already happened once. The evidence is still there. The 1814 eruption was not an anomaly. It was the upper end of a pattern. In 1897, Mayon erupted again in what became the second deadliest eruption in its recorded history. A 17-hour violent phase that sent pyroclastic flows racing down to the shoreline of the municipality of Santo Domingo, killing 350 people on the coast. In 1993, another eruption killed 77 people, including scientists and tourists who were above the safe perimeter. In 1984, the eruption was significant enough to require the evacuation of more than 73,000 people. In 2023, just 3 years ago, the danger zone was expanded to 7 kilometers. Over 10,000 residents were evacuated from within the 6-kilometer permanent danger zone, and the world moved on to the next news cycle within 2 weeks. Mayon kept erupting. The people of Albay went home. The mountain waited. And now, in 2026, it is doing what it was doing in the months before 1814, inflating, producing lava spines, generating hundreds of daily rockfalls, releasing sulfur dioxide in quantities that NASA can see from space, and doing all of this not in a sharp and sudden escalation, but in a slow, sustained, relentless expression of pressure that the rock beneath the mountain has been building for years. The question is not whether a larger eruption is coming. The question is when. And the geologists at PHIVOLCS, who are among the best volcanic monitoring scientists in the world, will tell you that they cannot answer that question. Not because they are not trying, not because the instruments are insufficient, but because the Earth does not send warnings in the form of deadlines. It sends warnings in the form of data, and the data it is sending right now from Mayon's flanks is consistent with an ongoing effusive eruption that could continue for months more exactly as it is, or could escalate to an explosive phase within a single day, with very little intermediate signal that would allow the difference to be predicted more than hours in advance. What makes this moment in the Mayon eruption particularly unsettling to the scientists watching it is the sulfur dioxide data. Sulfur dioxide, SO2, is released when magma degasses as it rises toward the surface. The amount of SO2 a volcano is releasing is one of the most direct measurements volcanologists have of how much fresh, gas-rich magma is actively moving toward the crater. The average SO2 output during the current eruption has been 2,166 tons per day. On February 4th, 2026, it spiked to 6,569 metric tons in a single day, the highest one-day figure recorded at Mayon in 15 years. Then, on March 6th, that record was broken. 7,133 metric tons of sulfur dioxide in a single day. NASA's satellites tracked the plume drifting southwest across the Philippine Sea in images that look almost apocalyptic. A brown chemical stain spreading across blue ocean as if the mountain were bleeding into the sky. Fresh, hot, gas-rich magma, lots of it, moving upward. And the mountain continues to stand there, flowing steadily, and the scientists watch their instruments, and the alert level stays at 3. Now connect this to something the viewer needs to understand about the larger system Mayon inhabits, because this mountain does not exist in isolation. The Philippines sits at a geological crossroads of extraordinary complexity. The Philippine sea plate, moving westward at approximately 8 centimeters per year, 8 centimeters about the width of 3 fingers, moving every year without pause, without rest, the quiet relentlessness of tectonics, is subducting beneath the Philippine archipelago along the Manila Trench to the west and the Philippine Trench to the east, both of which are among the deepest oceanic trenches on the planet. The Philippine Trench reaches nearly 10 kilometers below sea level, 10 kilometers of ocean overlying a slab of descending rock that is being heated and pressurized as it sinks, releasing fluids into the overlying mantle, lowering its melting point, generating the magma that feeds volcanoes like Mayon. The eruption at Mayon is not a local event. It is the surface expression of a planetary process, the slow, grinding consumption of oceanic crust that has been underway for millions of years and that will continue long after every structure currently standing in Legazpi City has been returned to dust. And this is where the picture becomes genuinely larger, because the Philippine tectonic environment in 2026 is not geologically quiet outside of Mayon. The country is also home to Taal, a volcano that sits inside a lake just 70 kilometers south of Manila, a megacity of 22 million people. and which the PHIVOLCS monitoring network has been watching continuously since Tall's 2020 eruption sent a phreatomagmatic column 15 kilometers into the sky and forced the evacuation of over 500,000 people. Canlaon on Negros Island has also been showing elevated activity in recent months. 3 of the Philippines' most dangerous volcanoes simultaneously expressing unrest. This is not coincidence in any mystical sense. It is the inevitable consequence of sitting on one of the most geologically active plate boundaries on Earth. But it does mean that the monitoring resources and emergency response infrastructure of one nation are being asked to watch multiple serious threats simultaneously. There's also this, and this is the part that connects the Philippine volcanoes to a system that operates on a scale most people never think about: solar activity. The relationship between solar cycles and volcanic or tectonic activity is an area where the science remains genuinely contested, where serious researchers are beginning to gather data that suggests gravitational and electromagnetic forces at the planetary scale may have measurable effects on the movement of magma within the crust. We are currently in solar cycle 25, which reached its peak in late 2024, with solar activity significantly exceeding initial predictions. Extreme ultraviolet radiation, enhanced solar wind, geomagnetic storms reaching G4 and G5 class strength on multiple occasions throughout 2024 and 2025. Whether these solar maximums correlate with increased volcanic or seismic activity remains a question that the data is still being gathered to answer. What the cosmic perspective asks us to consider is that this planet does not exist in isolation either. It turns inside a solar system, within a gravitational and electromagnetic field that varies over decades and centuries, and the deep processes that drive volcanic eruptions, mantle convection, magma chamber pressurization, tectonic plate movement, operate within that larger field. The Earth breathes, Mayon breathes. And what looks like a local disaster is always, at some scale, a symptom of something planetary. Return now to the slopes of Mayon, because this is where the story lands in the bodies and the lives of the people who live there. In the barangays, the villages that sit between 8 and 12 kilometers from the summit, outside the current mandatory evacuation zone, but inside the zone that would need to be cleared if the alert level rises, there are families who have already evacuated once and gone home and are now watching the mountain again. They know Mayon. Their grandparents knew Mayon. That is the actual physical daily reality of living in the shadow of one of the world's most active stratovolcanoes. A reality so normalized by generations of coexistence that the evacuation orders can feel abstract, even bureaucratic, until the night the Yuzon comes and it moves at 200 kilometers per hour and the question of whether to stay and check the farm one more time has already been answered forever. The monitoring is in place. Detection is possible. Prediction is not. PHIVOLCS has seismometers positioned around the mountain at multiple elevations. It has tilt meters measuring ground deformation in real time. It has GPS networks tracking the inflation and deflation of the volcanic edifice to within centimeters. It has gas sensors measuring the SO2 flux at the summit. It has webcams and thermal imaging and satellite feeds from NASA and ESA providing data around the clock. And all of that data, the 308 daily rockfall events logged in the week of April 7th to 14th, the 34 to 254 volcanic earthquakes recorded daily in the same period, the 5 to 36 tremor episodes lasting between 1 and 36 minutes, the SO2 readings averaging between 1,536 and 2,428 tons per day. All of that data says one thing, clearly and without ambiguity. The eruption is ongoing, the system is active, and the parameters that would indicate escalation toward an explosive phase remain present. What that data cannot say, what no data from any instrument on Earth can say, is whether tomorrow will look like today or whether tomorrow will look like February 1st, 1814. The volcanologists of PHIVOLCS know this better than anyone. They work in a discipline where being right 99 times out of 100 is not enough, because the one time you are wrong, the one time the mountain does something the instruments did not predict with enough warning to move the people who needed to move, is measured not in missed forecasts, but in bodies buried under meters of volcanic deposit. They issue their bulletins with the careful, measured language of scientists who understand that every word they publish will be read by people who are deciding whether to sleep in their house tonight or in an evacuation center 15 kilometers away. That careful language, magmatic unrest continues. Hazardous eruption scenarios remain possible. Entry into the permanent danger zone is strictly prohibited, is not bureaucratic distance. It is the weight of knowing that what they cannot tell you might matter more than what they can. Minutes are not hours when a pyroclastic density current is moving. The 1993 eruption of Mayon killed 77 people, including experienced volcanologists and guides who were above the recommended perimeter, because the transition from fumarolic activity to explosive eruption happened in a span of time that offered no meaningful window for escape. The thermal energy contained in a single pyroclastic density current from Mayon, a collapsing column of superheated gas, ash, and rock fragments moving at velocities that exceed those of a Formula One racing car, is equivalent to several Hiroshima-scale atomic detonations released horizontally across the landscape in a matter of minutes. The town of Kagasawa was 7 kilometers from the crater in 1814. The current 6-kilometer permanent danger zone places the evacuation boundary at a distance shorter than the pyroclastic flows of that eruption reached. This is not meant to induce paralysis. It is meant to produce the kind of clear-eyed understanding of what is actually happening on the slopes of an active stratovolcano in April 2026 that the news cycle, in its brevity, almost never provides. The eruption at Mayon has now been ongoing for over 100 days. 100 days of lava flowing. 100 days of rockfalls, of tremors, of sulfur dioxide pouring into the atmosphere in quantities visible from orbit. 100 days of families displaced from their homes inside the permanent danger zone. 100 days of scientists watching instruments and writing bulletins and waiting for the mountain to tell them, through whatever signal the mountain chooses to send, what it intends to do next. What the volcanic record shows, not as speculation but as documented geological and historical fact, is that Mayon does not signal its largest eruptions with weeks of clear preparation. The 1814 eruption was preceded by earthquakes beginning the night before. The 1993 eruption escalated with almost no warning. The system that produces these events is continuous, not episodic. The same magma chamber that is currently feeding the lava flows down the Basud and Bonga gullies is the same body of molten rock that produced the Plinian column that turned the sky black over Albay 200 years ago. The pipeline between the deep source and the surface crater is open. It has been open since January 6th. It remains open now. Legazpi City is visible from Mayon's slopes. On a clear night, from the upper flanks of the mountain, you can see its lights spread across the coast below. 220,000 lives arranged on a coastal plain that has absorbed Mayon's volcanic output for thousands of years, that has been buried and rebuilt and buried again, that still carries the geochemical signature of every eruption in Mayon's recorded history in its soil, its rivers, its seabed. The people there are not unaware of where they live. They have grown up with the mountain. They have watched it glow on festival nights. They have sheltered from the lahars. They have lost relatives and rebuilt homes and planted crops in the ash-enriched soil and started again. That resilience is real, and it is extraordinary. And it does not reduce by a single cubic meter the volume of molten rock that is still sitting on those slopes. The lava flows are measured, they are tracked. 3, 8 kilometers in the Basud Gully. 3, 2 kilometers in the Bonga Gully. 1, 3 kilometers in the Miisi Gully. Those numbers represent the edge of what is currently moving. What sits behind those flow fronts, the accumulated semi-cooled, unstable mass of volcanic material stacked on slopes that average 30 to 35 degrees, represents a secondary hazard that will outlast the eruption itself. When the rains come, and in the Bicol region, the monsoon season arrives between June and October, historically bringing rainfall events measured in hundreds of millimeters in a single day, that accumulated volcanic material becomes fluid again, not as lava, but as lahar, capable of traveling far beyond the boundary of the lava flows themselves, capable of reaching communities that never appeared in any previous hazard map, because the volume of volcanic material now on those slopes is greater than it was during any previous lahar event in recent history. The question the science cannot answer, sitting over this mountain and this province in these 100-plus days of sustained eruption, is not whether any of these scenarios is possible. They are all possible. Some of them are probable. The question is the one that the farmer in Camalig, watching the crater glow from outside his window at night, has been asking silently since January. Not what could happen. Not what the instruments show. The question that sits in the space between what science can measure and what the future contains, the gap that no instrument has ever been built to close, is simply, tonight or not tonight? The mountain does not answer. It glows. It exhales 2,000 tons of sulfur into the sky. The seismometers tick. And somewhere in the deep, slow machinery of the Earth, in the column of rising magma that connects the Philippine sea plate's subducting edge to a small crater at 2,462 meters above a city full of people who have known this mountain all their lives, pressure builds at a rate that has nothing to do with the human calendar and everything to do with a geological process that began before this species existed and will continue long after it is gone. The ruins of Kagasawa have been standing for 212 years. The bell tower rises above the Lahar Plain in the shadow of the same perfect cone. The mountain that buried the town is still there, still glowing, and in the week of April 8th to 14th, 2026, It recorded between 34 and 254 earthquakes every 24 hours. That is not silence. That is a conversation between the deep rock and the surface that the people of Albay have been living inside for generations. Whether the next chapter of that conversation is written in weeks or centuries, the science cannot say, but the instruments are listening. And so, somewhere in the warm volcanic dark above Legazpi City is the mountain.